looking at review 9A, a bunch of volumes here. Volumes and areas we got to figure out. We're going to do some graphing. So let's graph this first one. Y equals x squared is a parabola. Y equals 2x is a straight line. Okay, and we're actually going to try to figure out the area between those two. And so we're thinking about adding this up here, those little rectangles. We're going to add those up from that point to that point. To figure out this second point, we're going to set the two equations equal to each other and solve. And x squared minus 2x equals 0. You're going to get x equals 0 and 2. Those are your integrand limits. Shrink this graph back down here. And so you're going to end up with, this is the area, 0 to 2. Top minus bottom, 2x minus x squared. The top function minus the bottom function dx. Okay, and we're just gonna set these up right now. Okay, so that is your answer for A. For part B, we're looking for the volume. I've drawn it here. Should be able to replicate that. I'm going to use washers. Move this off to the side here. And so we would want to write that, that we're using washers, on the test. And find the volume, therefore. And I just write down, I want pi outside squared minus inside squared. And this is a dy situation, so a little slice of the y-axis. Okay, so I'm looking at the outside function squared minus the inside function squared. The outside function, I have to have everything in terms of y, so I got to write both of those beginning equations in terms of y. And so I'm going to get square root of y is the outside function squared. The inside function is 1/2 y squared dy. And you're going to stack these washers up from 0 out to 2. I'm sorry, that's not 2, it's 4. Your y value there is 4. Okay, the x value was 2. If you put 2 into either equation, you'll end up with 4 as a y value. So it's 0 to 4, and that would be your integral. Okay, V I'm kind of working on here. You're drawing this volume again. You have the original parabola there. You're spinning it around the y-axis this time. So it creates a three-dimensional shape, maybe like an upside-down jello mold or something like that. Okay, and I want to use shells. Okay, so I'm going to draw a little shell in here. A representative shell, and let me do that just a little bit better there. Well, it was supposed to be better. There's your representative shell, and the reason I chose shells because that gives me, when I use shells, it's going to give me a little slice of the x-axis, so that's going to be a dx situation. I like the dx situation because the original problem is written in terms of x. It would be very tough to solve that for x, right, in terms of y. Okay, you'd have to use a quadratic formula, and so a dy situation would be tough. So we really want the dx situation, and so that's what we have when you use shells. So you're thinking 2 pi rats. We're going to put a 2 pi out here in front. The radius is x, and then the altitude is the distance from the top to the bottom of the shell. Okay, and so you are really looking at the top of this shell to the bottom. So that should be that function minus 0. So I've got that as 2x minus x squared, and it's 2 pi rad. So that's my radius, that's my altitude, that's my thickness. I'm going to add these shells from the inside to the outside, from 0 to 2, and that is my volume function. We're just going to set those up, is typically what you do a lot on the AP Calc exam. On to number 27. Draw an A there. Find the volume of the solid when you revolve it around the x-axis. And so we end up with that three-dimensional object there. Pi r squared h, we're just using this here. So we're going to have pi r squared is the function in terms of x squared dx, and we're going to add this up from 1 to 2. So that is your answer for A. And we're trying to draw B. It should look like this. You're spinning it around. X equals 3. Okay, and so that original shape spins around here. Comes over there. It's kind of tough to draw all this, so I'll see what I can do here. Kind of imagine this three-dimensional shape coming together, and looks to me like shells is going to be your best choice. So there is a representative shell, 2 pi rat. Here's my little formula. 2 pi, the radius is, it's along the x-axis, it's going to be 3 minus x. The right minus the left is going to be 3 minus x. The altitude is going to be the top function minus the bottom, which is 1 over x. And this is in a dx situation. I probably should have written that first. And we are adding up these shells from 1 to 2 along the x-axis. So that can be a little confusing. Take a look at that, see if that kind of makes sense to you. That's where that volume function should be. So looking on the second page of 9a, we're going to skip 48 if that's on your sheet. That seems a little bit too cumbersome to be a representative problem that would be on an AP Calc test. I want to move to 59. That's a much better problem. Trying to draw this out, it's tough to kind of represent all of this. Find the area of region R bounded by the line y equals e. That's weird to write it that way, but that e is just a number. So y equals e is a line straight across there. The graph of f, which is your e to the x squared, is your exponential growth of some sort. And the y-axis, and so we have that little wedge in here that we're trying to figure out the area of as I see it. And so I'm going to add up just a representative rectangle, if you will. That's a dx situation, little slice of the x-axis, top function minus the bottom function. And I add those up from 0 to 2. 0 to 2. Now, how do you know it works at 2? Okay, so you're trying to figure out, this is along the x-axis, so you're trying to figure out this point over here. And so you're trying to figure out where those two lines match up, where those two functions match up. So e equal to e to the x squared, x over 2 power. Those match up when 1 equals x over 2 or x equals 2. So that gives you, you know, this occurs, this point over here occurs at 2 along the x-axis. And so that becomes your answer for A. Okay, I'm moving on to part B of number 59, trying to figure out the volume. Okay, so this is when you revolve it about the x-axis. Okay, so the x-axis, I'm going to write that in there. Okay, I can spin it around. I have my original area. I'm going to spin it around. And so you have that other region forming, and actually this is going to make a volume. Okay, so I kind of tried my best to kind of sketch that together. I'm going to go ahead and I want dx's, so I'm going to use washers in this situation. So I'm going to put a representative washer in here. Something like that. See if you can kind of see that washer. I'm trying to get it to the edge here. I'm always trying to make sure this goes to the edge there. Okay, if I were, yeah, that's not going to work. Trying to hit those edges of the functions there. Let's see what we have here. If we can figure out B, you want a volume. And let's see here, our volume is going to be washers. We said that. So I want pi outside squared minus inside squared. Okay, so I'm going to go pi. Outside squared is your line, which is just e. So you have e squared minus inside squared is your e to the x over 2 power squared. And this is a dx situation. You're counting these up. You're stacking them up from left to right from 0 to 2. So that becomes your function there. That will give you the volume. And that's the last problem.